It's important to understand that when we want to differentiate y in regards to x, we can only do that if y is a function of x. Say like that. If that's not the case, we cannot differentiate y in regards to x. We'll continue in a minute. Let's continue with derivatives. We'll continue with the chain rule and implicit differentiation. An example how do we do that. So just to remember, the implicit differentiation, the chain rule states that dy differentiated by x equals the same as dy by du times du by dx. So, some cases where we can't get a function with respect to x, we use so if the function looks like, for example, 3x squared minus plus x y on the third equals say 2y on the second degree. So because x and y are tied together, if you want to differentiate with respect to x, we'll have to apply the chain rule. So now let's differentiate in respect to x the first one, so it will be 3 times 2 times x, and then plus. So differentiate the second one in regards to x will be the chain rule because it's a product. The product. How do we differentiate the product? That's also one of the rules. So differentiate the first one in regards to x. So we want to differentiate both sides in regards to x. That's what we said. So if we differentiate xy, so differentiate first one in regards to x, we get 1 times, the product rule says first one differentiate times the second one, plus the product rule says then the first one times differentiate the second one. But the second one is differentiation of y on the power of 3 by dx. So on the other side, if we have differentiation of 2y squared by dx, so we can't differentiate y in regards to dx. We can only differentiate y in regards to y. Therefore, so this is all the same, but this bit here we have x times, now in regards to y, if we differentiate y on the third, is 3y squared times, we differentiate, so we differentiated y in regards to y, now we have to differentiate y in regards to x. So that's that rule. So it's like crisscross. They are the same variable. So now we differentiate y in regards to x equals the same here. We can't differentiate y in regards to x, we can differentiate y in regards to y, so it will be 2 times 2 times y times differentiate y in regards to x. So I hope you're getting it there. So now let's move this whole lot to the other side, because then we have the common factor, and what's left on the left hand side, we have 6x plus y on the power of 3 equals, on the other side we have common dy by dx, and we have 4y minus 3y squared times x. And then the last step, we have differentiate there, and then we need to move this expression from the right hand side to the left hand side, so it's multiplying here. That means on the other side we'll be dividing. So what's going on here? 6x plus y on the power of 3 divided by 3 minus 3y squared x plus 4. Let's write that better, nicer. So it will be divided by, so the common factor here is y, so we can take y out, and we have 4. We have, because it's going on the other side, the signs will change, so instead of 4 we have minus 4. Oh, sorry, because it's dividing. I apologize, not dividing. So we're taking it to the whole side, so both sides divided by the same expression. So what we're getting is y there, and 4 minus 3y x, and that's the final, that's the result. So we can take different color for it. That's our result of differentiating that bit there using the chain rule, and it's called implicit differentiation. So we got implicit differentiation using the chain rule. Differentiation using the chain rule. And something a bit more for today is that we'll focus on more formulas, so some additional formulas. We'll do them in a different color. Yeah, so our formulas will be for the functions like sine, inverse functions, right? And we'll do some more formulas. Like, what would it be? Let's make a cross. Oh, not quite good one. Will be f of x here, f prime of x there. So the inverse function of sine of f of x, what would be the first derivative? But it will be very similar to what's the first derivative of sine of x. the inverse function, so it will be f prime of x divided by the square root, the same as before, and then we have 1 minus, and instead of x square we have f for the x square. So that's for that. So let's now go to cosine. So r cosine, or the inverse cosine function of f for x, it's similar like before, and it's, what did we have there? We have f prime of x, and it's with a minus in front, because before, remember, was minus 1 up there, and under the line we got 1 minus, and the same thing, f of x on the power of 2. So that would be our inverse function of cosine when its argument is a function. So when its argument is a function. So formulas where the arguments are functions. So arguments are functions. We can write that there. Okay, and one more is left, is the tangents. The same thing. You have tangents. Tangents from the inverse function of f of x. And like before, the tangents we have, where one is, we have the first derivative, the function, and we have, of course there is no square root there because it was a divided by a square plus x square. So we're gonna, instead of a, we're going to put 1 like we did before, and instead of x squared we put our function. So it's very similar to the inverse trigonometric functions where the argument is an independent variable x. The only difference is that where we had x, where we had 1 in the denominator, we have the first derivative of the function, and where we had a square, in this case it's 1 because if we just had simple x, it will be 1. So there is no difference there. The only problem is, the only difference is where x is, you just employ f of x, and where 1 is in the denominator, you put f prime of x, and that's the only difference. So it's f prime of x divided by square root of 1 minus, for the sinus, 1 sine inverse function arc sine 1 minus f of x squared, minus f of x on the power of 2. And let us do one more formula where the argument is a function, and that is the logarithm for the base of v of f of x, absolute value, that's f prime of x divided by f of x. That's all for this time.